Hi. So at this point, we want to take a look at the simple mathematics we can use to measure similarity between two entities using interest that we know about them. And like I said, this can form the foundation for building online matchmaking for online dating sites, or it can also form the foundation of a very simple recommender system where you want to recommend new content to people based on what you know about them and what you know about other people who are similar to them. And so, to help you understand that, I'm making us take a look at this Wikipedia page. And if you do not like mathematics, I want you to ignore all these things you are seeing here. And trust me, it's all going to make sense to you in a matter of 3 minutes, okay? So, the mathematical technique we are going to learn about is called Jacquard Index, or Jaccard distance, or Jaccard similarity, or Jaccard similarity coefficient. Whenever you hear all these mambo jambos, what you need to remember is that it is a simple way for you to measure the similarity between two entities given some known likes or dislikes about them, okay? Before I explain this formula to you, let's take a look at what is happening here. This is set A, which is colored in something like, I don't know if it's yellow. I'm not very good with colors, but let's say A is yellow. So this whole circle, and then the B is something that looks like, I don't know if it's green, but the A intersection B, which is this region that has the light blue color, is everything that belongs to A and also belongs to B. So that is what we were able to calculate using the union method, okay? The intersection method. And the union operator pretty much puts everything in A and B together, avoiding duplicates. And that is what we were able to do using the union method. Now, the Jaccard index is calculated by simply dividing the number of common items between the two sets over the total number of items in the two sets. So in set notation, when you see these vertical bars, it is also known as the cardinality. And the cardinality of a set is just the length of items in the set. You know, mathematicians like to make things complex. So the length of items, which we have already calculated using the LEN operator, is what is known as the cardinality in mathematics, okay? And so if I find the union of two sets, remember that I get a set back. So to get the cardinality of that, I just need to call LEN on that result. And the same applies to the union. When I do union, I get a new set and then I call length on it. If I do intersection, I get a new set and I call LEN on it to get the cardinality. So basically you are dividing the common interest by the total interest, and that is going to give you a number between 0 and 1, and you have the right to choose what your threshold is. So if I am building matchmaking algorithm for an online dating website, then I can say, okay, if somebody is similar to another person above 0.7, then they are a good match, and so we are going to show them to each other. Otherwise, we won't even bother to show them to each other. So let's set 0.7 as the threshold for our matchmaking algorithm, okay? So I'm going to create threshold is equal to 0.7, okay? All right, so now we know the interest, like this is their total interest put together, and then we also know the common interest over here. So we want to calculate similarity score. So I'll say similarity score. And the similarity score, like we saw in this formula, is just the cardinality of A intersection B divided by cardinality of A union B. And the cardinality here is just the length, okay? So the length of, we want the length of their common interest. How many interests do they have in common? Divided by the length of the total interest that they have. So the interest of both man and woman. But remember, we want to do integer division. So depending on the version of Python you have, this might work, or you might also have to force one of them into a float. Remember that the len is going to return an integer, so we want to force one of them into a float so that we can have something that is not only integer division, where the fractional part is going to be truncated. Okay, so let's print their similarity. So I'll say similarity score for these two people. So I'll say similarity score, and I think I've forgotten the F here. All right, so let's come and run this program and let's see what we're going to get. So I'm going to run this, and it says that the similarity score for these two people is 0.2222. So indeed, as far as our threshold is concerned, these people are not a good match. Okay, so we print the similarity score, and we can say if similarity score is greater or equal to threshold, then we print perfect match found, or a match is found. A match is found. Okay, otherwise we can say not a match. Okay, so we already know what we're going to get for this program. We know they are not a match because our threshold is 0.7 and the similarity score is 0.22. Let's see if we can make these people become a match. Well, if I should copy all the interests of the woman and paste it for the man, so it's like the woman has found a man who has exactly the same interest as she does. Let's see what is going to be the similarity score here. And indeed, you can see that the similarity score is 1.0, which is a perfect match, which only happens in fairy tale movies. Okay, so it says a match is found, and the reason is that the similarity score between the man and the woman is 1.0. Okay, let's bring it down. Let's not be so optimistic. So let's say instead of yoga, this guy likes running. Let's see how that affects their similarity score. So you can see that the similarity score has dropped, and see how quick it can drop. A simple difference between them brings them to 0.71, which is slightly above our threshold. Okay, so let's say aside oranges, the man likes his banana. Okay, so let's run this, and you can see that it brings their similarity score to 0.625, which is not a match. So maybe we are being too strict with this, our matching algorithm. So let's just change this to 0.55, so that if you are above 0.55, we think you are a match. Then this is going to be, it's a match, okay? Because 0.625 is about 0.55, and that makes them a good match. So as you can see, we have been able to learn a simple algorithm for calculating similarity between two entities, and like I mentioned, this forms the basis for being able to build matching for online dating sites or recommender systems, or any use case where you need to compare two entities and be able to assign a mathematical meaning to how similar they are. So thank you very much for watching this, and I'll see you in the next